Hi, everyone, and welcome to my talk. This talk is very special for me, as it's a bit unusual, as you will see very, very soon. The title of the talk is A Road Towards the Chain Rule, which might feel a bit mysterious, and hopefully during the talk, everything will make sense. I'm super grateful to have been invited by the LatinX group to give this keynote, and I believe this is the first talk of the day. And at the same time, the year is 2020. I recognize there have been many, many challenges we all faced that actually prevented us to be in person, seeing each other. So I hope you're well at home and that you're having a good time assisting these virtual NeurIPS. So, as I said, the organizers have asked for a talk that contains kind of a mixture of your personal experience in the field of machine learning, plus then a topic you're passionate about. So I'll connect sort of roads and learnings on a kind of a person from a very personal perspective on what my career has been. Hopefully, you'll recognize some patterns, some learnings that I've personally experienced that might be helpful, or you might, just link to your own experiences and just create a good space for discussion for later. Now, these roads lead to the chain rule, which will be the second part. But this part of the talk is very, very special because it's not the kind of talk that I'm used to in terms of being very technical or being sort of an overview of the field of AI or machine learning, but rather more of a personal view on academic research careers, etc. Hopefully, it's going to be a good experiment and you'll enjoy the talk as much as I've enjoyed both preparing the talk and thinking about these topics carefully and reflecting upon one's sort of path to where you are now. And obviously, maybe it even helps you understand where the road is leading towards in the future. So I created this visualization, which we'll be working through the first half of the talk. And the visualization essentially is a sort of a timeline. I started this timeline when I started my studies in the Polytechnical University of Catalonia in Barcelona. I'm from Spain. And so the very beginning of my sort of academic career and discovery, perhaps I put it when I started undergraduate university. And then, I kind of visualized this through the last 20 years, really, to see what kinds of decisions and what kinds of things happened, right? So clearly I was, for a while studying in Spain. Then I went to the US. I studied master's. I did a PhD. Then joined Google Brain initially in California, then moved to London and joined Google DeepMind. And so looking at these, one feels like, oh, that's great. That's you have great help and some, quote unquote successes, right, with internships and great opportunities. But at the same time, there is a very different view that one must realize is perhaps equally, if not more important, which are the failures, right? So the same visualization. What were challenging moments that happened throughout my career? It's quite kind of revealing to almost visualize them. Now here they become quite more dense in terms of rejected papers and failed decisions and whatnot. So it's not that there are no failures here; it's that there were just too many to list, and I wanted to focus towards kind of maybe the more academic and learning part of your career here on the left. But clearly, there's been quite a few interesting events in my life. In fact, I was rejected from a Google internship, despite the fact that I've been now at Google for a few years, and rejections, fellowships not given, etc., right? So it's quite interesting to think about failures as much as it is interesting, of course, to think about things that went well as planned, etc. So let's start perhaps with a slightly different view of this timeline, which at the top there's going to be just some sort of event, like a academic driven event, and then at the bottom I'm going to try to visualize from memory mostly what my goal at the time was. And you'll see also that it's not even clear that the goals are, that you have this vision that you will, in 20 years, I want to be here or there. You will see a lot of goal sort of changing, right? Dynamism, if you will, which is quite interesting as well as you sort of go through this exercise. So I would say before, when I started university, my main goal was really, get passing grades on the subjects I was taking and try to minimize the study time. I do quite like video games. I was playing StarCraft, which came back later, as you will see much later in the talk. And that was fine. But there was a reality check at some point in the class of vectorial analysis. I got a 2 out of 10 grade, which is not great. And that kind of triggered one of the most important thinking, which is, to me, that failure, right? That grade really triggered a motivation to actually be better, right? And I think this is a pretty universal, at least, truth that has worked quite well for me, which is like the failures are what often has motivated me more than important successes, right? I think, realizing what a failure is and just trying to get back up has been personally quite critical for decisions that I've taken in my life. And perhaps the one I remember as being very early is these 2 out of 10 in this exam. So do not ignore failures. Don't try to just kind of swipe them under the rug, right? Just own them and understand how your own goals might change thanks to these failures that are very necessary, I think, for one's development, right? So as I got this failure, I kind of changed my goal to, okay, I want to get good grades whilst minimizing study time, right? And I think that refined goal was a bit better in retrospect. Now, things that happened during my university years in undergrad was that Tomás Lozano Pérez, who is a great researcher originally from Cuba, who is a professor at MIT, came to give a talk, an inauguration talk of a center for dual degrees in my university, and sort of talked about how AI actually is this amazing field that connects many different, if you will, like areas of research, right? Like from mathematics, of course, biology, philosophy, computer science, etc. I really was fascinated by that talk, and it really impacted me, from a personal standpoint. And I just kind of realized, okay, maybe my main goal right now would be, actually, I want to explore the idea of studying abroad and do an undergrad thesis there. An undergrad thesis is something that it might not be very common in some countries, but in Spain, you have to do a thesis for about 6 months or so. So that changed my goal to like, okay, maybe I want to actually go abroad to study. Now, at the same time, and the inauguration of this was precisely to inaugurate these dual degree programs, I started studying, besides telecommunication engineering, mathematics. And, I sort of realized maths are quite useful. And this is a truth that even today I apply every day to kind of learning research and new ideas for new models, right? And there was this sentence that somehow stuck to my mind, which Pera Pascual, who is a professor in the mathematics department, said. He said something like, people in robotics use a 46-dimensional manifold, right? Now, to this day, I actually don't know what he meant. I actually met him many years after, and I asked what he meant by this, and I don't think he remembers saying this, but somehow I remembered that one sentence, and I thought, wow, okay, what I'm learning here, I actually will connect it to perhaps an important domain in the real world, which is very fascinating. And one of the things that maybe as you study some more abstract notions, you get to only discover much later. It is very nice, though, to make these connections as early as you're learning the new concepts. Now, a bit further into 2005 or so, I started working in something that, in retrospect, actually defined my career as well, which was, there was an open project led by Antonio Bonafonte on learning to generate a Catalan voice, which is Catalan is obviously the language that we speak in the region of Barcelona. And, I started to play with some open source software called Festival to train a text-to-speech system that would be able to speak in my language, right? And that was kind of an interesting experience. And the experience allowed me to see what is research about. Not everything. Up to that point, to me, everything was kind of getting the best grades that I could. But actually, this process of doing research in the university in Barcelona really was an enriching experience. And I would say that in life, not everything is all about best grades. Try to enrich and widen your CV as much as possible with diverse experiences, right? So that's a lesson that it took me a few years to learn. But in retrospect, it's something that maybe, certain countries, I see this pattern a lot where there are very hard exams and the curriculum is really, really exhaustive, but you don't get exposed to research as early as you should, and definitely not as early as most people that are interested in research get into in the US, which is another country that later on I would live in, and I would kind of experience their university experience, so to speak. All right, so now we reach the point where I kind of achieve the goal of studying abroad. I go to Pittsburgh, Pennsylvania, CMU with Fernando de la Torre, and I work on my undergrad thesis. And there is where I start sort of really learning, some very core concepts in machine learning. And I decide that I wanted to study a master's beyond my undergrad. And there were some fellowships available to us in Spain given from banks, which is quite an interesting concept and quite nice, actually. And that was kind of, at the time, I changed my goal. Okay, I wanna work on a master's with a fellowship. Now, here is a very important lesson that I learned that I hope you have the opportunity to do yourself if you're not doing it already, and see whether you agree with this, which is the experience of living abroad and getting exposed to a much wider and more diverse network of friends and colleagues is probably one of the best decisions I've ever made. The world is bigger than the city you live in. I think it's very important to recognize the richness and diversity of our world, especially in a year like 2020. So this to me is like, okay, that is maybe the one piece of advice that I give to people that maybe email me asking for advice. This would be maybe the one that I would extract from my whole experience in my research career, right? So at the same time, I said, okay, I want to do a master's. I do applications. Of course, I target one of the best universities out there, which is MIT. And I actually got rejected, which wasn't great. As one of my friends said, there is a tree at the MIT campus that we sponsored thanks to the application fee, I suppose. I would like to know which one is it when I visit next. It's a beautiful campus, actually. But yeah, this didn't go as planned. And, finally, through perseverance and so on, I got into an internship at Berkeley in California, which I gladly accepted to do research, again, continuing on speech recognition and so on. Now, during my studies in Berkeley, early days, I also was given the nice opportunity to go for a Microsoft research internship, and that also was career defining because that was very early days, right? This was pre-2008 even. But thankfully, many of the University of Toronto students were doing internships. So I got exposed to the ideas behind deep learning, which obviously later would define my career very clearly so. Now, at this point, having been at a laboratory like Microsoft Research, it was very, very clear to me that I wanted to pursue a PhD. So the master's wasn't going to be enough. Many people doing kind of long-term research had PhDs. So I thought, okay, that's what I need to do. And that's what my goal was changed for at the time, right? And at the same time, thanks to these failures and knowing more and more people in the field, you realize how important it is, the network that you create, your group of friends and colleagues, because even though you might have a good CV, it's not easy to get into, nice fellowships, internships, and university applications. So don't underestimate the connections you're making as you're sort of navigating around, perhaps a bit random walking initially, wherever you can, to visit and get these new experiences, right? This is also quite an important aspect that I learned perhaps around this time with these rejections and acceptances eventually onto these programs. Now, I got lucky to get into a master's program, thankfully, and I lived for a year at the beautiful campus of in San Diego at UCSD, and at the same time, the same year, I tried for a PhD again, and I got a few rejections. In retrospect, things like my statement of research were not very well written, so there are good reasons for it to be rejected, but you have to go through these rejections to persevere and learn, really, right? So eventually, I was lucky enough that Berkeley accepted my application, and then I began my PhD in late 2008 at UC Berkeley. And at this time, my goal, I'm in the PhD program. My goal is to change my focus, my research focus, from speech recognition and all these applications that I started even from the Barcelona days towards more general AI and machine learning. And this is actually quite important. Changing subfields. If you're not 100% convinced that you're really doing what you want, is not only recommended, but often necessary. Necessary because there's a nice loop-back connection you can make sometimes. And thanks to having worked so much on speech, actually, I became fascinated by sequences, which are actually one of the key areas of research that I developed throughout my career, really. But the focus being speech versus machine learning, it was important for me to connect the dots and have this perhaps higher level view of not only about speech, but any sequence learning paradigm that involves not only speech, but language and sequential decision making, etc., etc. So at the same time, I keep going to internships at MSR, a very important place for me. And at the time, I actually do an internship not only exposed to deep learning, but about deep learning. And I decide, okay, I do want to pursue a PhD in deep learning, but believe it or not, at the time, deep learning, we're talking 2009, 2010, deep learning is not even like a major topic of research in most universities, and definitely not a popular topic at Berkeley. So, obviously I was a bit on my own, right? I had to find my way. I had an obviously great set of advisors that helped me on the PhD kind of road. But at the same time, research-wise, I wanted to do this one thing that at the time was a bit not, mainstream, so to speak. Now, luckily, I obtained a fellowship that allowed me to have a bit of more freedom to explore this area of research, which was fascinating to me, although it was not necessarily mainstream. And that allowed me to then, okay, I will do a PhD on deep learning, at which point it was very clear to me that I wanted to pursue research in an industrial lab. And so the main goal became, well, I want to finish my PhD, obviously, right, to get to the next step. So I couldn't wait to finish my PhD. Still, PhDs are long, so there's a big gap here of a couple of years where I was still visiting and doing other things elsewhere. And one of the maybe critical moments was changing. Instead of going to MSR again, I decided to try for a Google internship again, which, as I told you before, was rejected the first time. This time I was lucky, and I got to intern at Google. At the time, Google had only a very beginnings of a program for deep learning. And interestingly enough, my first day was also the first day of another intern that was a very special kind of intern, because it was Professor Jeffrey Hinton, who had this Noogler hat with the helix and so on. And I remember very well meeting Jeffrey and he saying, "Oh, I'm also an intern," and it was quite good and quite inspiring to be around at Google at that very early times. Still 2012 was fairly early, although some industrial labs were already recognizing the power of deep learning. So at this point, I interned at two places that I love, Microsoft Research and Google Research. And so my main goal was, well, I want to get full-time offers and join as a researcher. And luckily enough, I got offers from both, and it was extremely difficult, painful, I would say, to the amount of back and forth to decide which of the two places to join. There's lots of backstories that I can tell you maybe in a different occasion. on deciding these, and it's really hard to decide many times amongst two options. And actually, these decisions, especially when the both options or the options you have are good, become increasingly difficult. And again, I get a lot of emails of people asking for advice on what to choose to do. Well, moving forward, I finished my PhD. I start as a research scientist at Google Brain, and my main goal really is now I learn from the leaders in machine learning and deep learning. I joined a great team, and I start focusing on a bit longer term perspective on my career rather than getting my thesis done, which was obviously the phase during Berkeley, right? And one maybe very important defining, self-defining characteristic is that of learning. So even after my PhD, learning is and will be my main driver and motivation, right? So I think we should never stop learning as researchers, and really everyone should embrace learning as the growth opportunity that we have in this modern era, that learning becomes very accessible through the internet, etc. So for me, that is, even today, I want to learn something every day, and I try to learn as much as possible. As part of that learning process, actually, a few years after, I decided to move to London to Google DeepMind, which is a very similar group to Google Brain in a way. And eventually, also, I became a manager, a team lead. So the kind of things that I learned besides reinforcement learning, which was one of the main areas of research that I wasn't kind of super familiar with, and I learned a lot since I joined DeepMind, is also to learn to be like a leader, essentially inspire others in their research. And that's something that never ends. It's a never-ending learning process that I truly enjoy. And up to this day, this is essentially my main goal in research. And obviously, there's many other academic goals and so on. But I thought this was summarizing my kind of personal experience in a way that I hope you found interesting. Last but not least, don't forget your agents, your teacher, professors, mentors, colleagues, and obviously also friends along the road that you've traveled. It's quite nice to be able to look back. So I thank the organizers to kind of challenge me with this kind of talk. And I'll dedicate the last 5 or so minutes to just give you a glimpse of maybe more of an academic aspect that really has defined me as a researcher, actually, besides these other things that define me more as a person, and obviously also as a researcher, but more from a kind of goals. What are your goals and priorities in academia? Which are the chain rule in actually plural? These are 2 principles that changed my research, and it's quite obvious to explain. I hope many of you might know these. What they are, but I'll just give you a very brief glimpse perhaps onto the chain rules. Now let's enter a bit on machine learning. Machine learning has a few components that pretty much everything can be defined through. Data is very important in machine learning. It could come from a labeled data set by someone who labels them, or it could come from an environment that generates experience, and you must optimize something. There is then a model that is a powerful approximator to map X to Y. There's a loss, which is utilized to fit parameters of this function. And last but not least, there's an optimization process. Actually, part of my most of my thesis I dedicated to the optimization part and a little bit of recurrent neural networks, which is F. So the nice thing about deep learning is that this F is composed by many layers of matrix multiplications and nonlinearities, which you might have heard about. If you haven't, there's so many references and tutorials that I cannot just give you a single pointer. Would be quite hard for me to do. But the first component, this F function that is composed of many layers, the critical aspect is that we can compute derivatives of the outputs and the loss with respect to all the parameters that are defined by these matrices. And the way to compute derivatives is quite well known. It's called chain rule, and it comes from the 17th century. Newton/Leibniz all used it in the kind of very beginning of defining what calculus is. And it's a very simple kind of a way to compute derivatives of complicated functions, compositions of functions. But thankfully, thanks to hardware and other advancements, we can compute these quite efficiently in memory and in also time to compute them. So that really allows the learning in deep learning to function well. It's this that is everything is differentiable, and the derivatives themselves can be computed in a quite elegant manner through the backpropagation algorithm, which relies upon the chain rule. Now, another chain rule that I wanted to describe is that of sequences. So remember, obviously, sequences have driven a lot of progress in speech. They have driven me personally first as the main topic of object of research, speech recognition, and then later just connecting the dots back to speech, but more from a machine learning general perspective. Sequence modeling in this kind of recipe can be seen very similar to actually supervised learning. Perhaps in sequence modeling, you just are given sequences. X's now have several observations, not necessarily of the same length. And your goal might be, I want to find a model such that when I evaluate it on the data, it's happiest, meaning it has highest probability. So modeling word probabilities or sequences in general is really difficult. It's really difficult because maybe as a first approximation, you could say, well, the probability of a sentence such as modeling word probabilities is really difficult, could be decomposed as the product of the marginals, right? The product of the word modeling, with the probability of the word times probabilities times is times really times difficult. And this model is just too naive. For instance, the most likely 6-word sentence would be the sentence "the" repeatedly. There's a massive independent assumptions that words don't depend on previous words, which is really damaging your modeling power. So what's much better is the chain rule of probability, which in a nutshell says, look, to decompose this joint probability across the whole sequence, you're going to just kind of have this divide and conquer approach, which is first, you're going to define the probability of the first word, then the second word given the context, the first word, then the third given the other 2 words, and so on and so forth. You can unroll this as much as you want, and you get a properly normalized probability that has no assumptions, makes no assumptions about the data, meaning it's a very powerful model, no assumptions being made, ergo maybe the model to be used for modeling sequences. The only problem with this model is that if you just naively model this kind of probability of word given previous word, you quickly realize that you need to have a lot of pairs of words because there are many words in most languages. And you get to this massive statistical issue of not enough data to estimate these pairs of words probability for all the pairs of words that are out there. And this is further increased in difficulty when you consider that, well, if instead of taking one word as a context, you take n words, this grows exponentially with the number of words of context. Even then, if we could somehow count the words for all these different contexts, if we limit the size of the context, which is what n-grams models have done up to like the last decade, which is where the most prevalent models, there is an independent assumptions being made that anything before the third word does not matter in terms of predicting the next word. And even then, these n-gram models become very, very large. There's, in this particular data set that Google released in 2006, there's I don't even know, like that's 1 billion 5-word sequences that appear at least 40 times. So there's already an upper bound, a lower bound here on the number of unique 5-word sequences that you need to count in a data set, which is not practical. So the key insight is we are going to predict the probability of a word given all the previous words, not through a table where we store the counts, but instead as a probability distribution of the word we're trying to predict, given a vectorized version of the context. And how do we vectorize context? Well, we vectorize context with a neural network. We could use a recurrent neural network, or we could use a transformer more recently. But the key insight is there's a function that depends upon some parameters, learnable parameters, that encodes all these onto a fixed size vector. And this is actually beautiful because this connects the two chain rules. This is an implementation through a neural network of the chain rule of probability. And to learn this neural network itself, you actually are going to use the chain rule as understood as the calculus chain rule to learn these parameters data. So I don't have much time to go through these, but there are many practical applications of the chain rule that I've used throughout my career. Maybe the most recent of which was this agent that learned to play the game of StarCraft, connecting to early days when I wanted to dedicate more time to maybe playing games than to study. But this is a nice kind of throwback connection. I recommend you take a look at this project. There's lots of resources online. But in a nutshell, this model actually utilize the idea that to create an action in this very complex video game where an action is composed of several subcomponents, you just break these subcomponents into a chain rule in itself. And then what you're going to do is you build the action from the ground up, saying, what is the action type? What is the delay to the next action? Are you queuing this action or not? You're basically creating a small language across actions that create this data structure that is very complex. It would be impossible to do this directly. And in this case, you use the chain rule to precisely do that. So with that, you create these cool agents that play the game. I don't believe the video will be shown. So let me just skip to...
Okay, thank you. Thank you very much, Oriol, for this presentation that is very insightful for all of us that are learning, are beginning our careers, or either like ending PhDs, joining industry. But the importance of failure, it's been amazing to learn all your path. So we have some questions here. For example, Joao Araujo, he's asking if you mentioned countries that have excessively hard undergrad courses and few research opportunities for undergrads. What do you recommend someone in such a country or situation to do? Stand out, improve to stand out their resume, especially given how much the competition has grown even for graduate degrees.
Yeah. Thanks first of all for everyone. Now I guess we're in the live section, so it feels a bit more natural to be doing the QA live, obviously. So yeah, that's a great point. I think when I was faced with this challenge at the time, I didn't even know, as you saw, what I wanted to do. So there was a research opportunity, and I just took it. But if you at this point already, you're doing your undergrad, you believe you want to do pursue some maybe academic career in industry or academia, a PhD, and so on. There's a few things you can do. The first and obvious one is to look for in your university to see whether there are faculty members that might be looking for people to work with that are motivated to drive research. That was actually what happened to me. I was lucky enough that there was a few faculty members that were interested in hiring, in a way, like undergrads interested. As I said in the talk, this is actually very common in America, in the US rather, but not so much in Spain as I was studying there. Now, because of what happened also in the last few years with open sourcing and accessibility really to more accessibility to the internet and more resources online, even if there are no such faculty members, you can and should try to learn about research. You maybe drive a project, reproduce a paper. There are quite plenty of opportunities, and even this conference being online, in fact, makes it far more accessible than maybe when it was in person in some cities, right? So try to reach out to people like-minded and try to find these opportunities online is what I would say, and I would do now if I had a clear idea that that's what I was going to pursue.
Thank you, Riol. There's another question from Kevin Bello. I have one high-level question. What are your thoughts on the progress or future of deep learning or combinatorial optimization?
Great. Okay, that's a great question. I am actually quite passionate about combinatorial optimization as an area of application where perhaps deep learning wouldn't obviously be that applicable, right? The way I see deep learning is a great kind of pattern matching tool that has worked so well in speech and vision and obviously language, where there's a lot of patterns and repetition. For combinatorial optimization, because these problems are kind of unnatural in a way. There might not be opportunities for deep learning. However, there is actually a large set of work, many of which will be presented at NeurIPS this week, I'm sure. And I will say that I actually pursued this throughout a few papers and research that I did, and now I'm doing with my group. And there's some exciting results, and actually I think deep learning will be able to outperform some of the commercial solvers for doing certain combinatorial optimization applications. I will say that we're actually at the process of maybe publishing one such result soon, so keep an eye for that. But moreover, there is a very interesting workshop in February, I believe, that obviously was meant to be on in person, but it will be online, from IPAM, and it's called something like deep learning and combinatorial optimization, so, or discrete optimization. So you might attend that workshop for far more insights, of course, but it's a very interesting topic indeed.
Thank you. And in the line of that, I have a question, like in what extent also probabilistic models will join deep learning, and we will have the best of the two worlds maybe joining. Do you think we can identify better which applications goes to each one?
Yeah, I really would like. I mean, as I said, obviously the chain rule is in a way like a form of a probabilistic graphical model, right? That with certain assumptions of like direction, if you will, right? That's what you do. But I would really love to see more and more tools from probabilistic modeling, graphical models, to sort of re-enter the field in from a maybe from a deep learning angle. There's a very important topic right now being researched in causality, which obviously would require these kinds of tools. And so I think maybe look for that space in particular on causality, but I would love for that to happen. I myself, my background from Berkeley was more on statistical probabilistic models. I studied under people like Mike Jordan, who obviously loves these models. So I would love to see kind of a bit more of like cohesion of the two subfields. Maybe I'm not the best person to try to do that, but someone who comes with that background maybe will be able to have some breakthroughs on that. But it's a very good field indeed.
Thanks. Another question from Diego Arribas. In your lessons learned part of the talk, you mentioned the importance of changing subfield. I was wondering if with positions both in academia and industry becoming maybe more competitive, this is becoming increasingly difficult to do, like changing subfields. Do you have any thoughts on this, or any recommendations on how to do this, switching fields?
Yeah, I mean, sure. This is a very good point, and I was making this because, at least in my case, I didn't radically change subfields, and this is something that you realize. Look, I'm specializing in speech recognition, but what I really am passionate about is machine learning. So you try to sort of force these changes in the conferences you submit to and so on as an undergrad or graduate student. Now it is true, I guess, that if you keep changing a lot, then you don't become a specialist on anything. That might make it difficult. However, if there is there is actually quite a lot to be said for people who actually enter machine learning from a different field. This is a formula of success that I've seen repeatedly. In fact, I suppose last week there was another example where people that have been studying protein folding for quite a long time, they joined DeepMind, and together with machine learning, they both learned about machine learning and developed an interesting result on protein folding with machine learning neural networks and so on. So I think, especially if you come from an outside field and then you start machine learning, that transition, I've seen it succeed many times, from physics, chemistry, astronomy. There's a lot of cool applications that people that have other fields and want to change to machine learning do. If you change within machine learning, I would say, as long as there's maybe a theme, if you zoom a bit out from like, okay, I'm doing sequence modeling with LSTM as well. I mean, you can change to sequence modeling using convolutional networks. You can change a bit more, but if the change is not too drastic, I will say this is very enriching. If you change drastically too many times, I agree, it might be a problem and not something I would suggest doing, especially later in your career. Many times, every few years you can do this, but it would have a cost indeed.
Thank you. Another question, do you have any tip to network with senior researchers?
Sure. I mean, the the tip I would, so as a student, I reached out to many people trying to get them to help me decide where to go to study and so on. So I think emailing people is obviously an obvious way that has worked for me in the past, and as a result I try to kind of, as much as I can, if I get emails with people asking for career advice, I try to make some time. Maybe it will take a few days, or sadly sometimes weeks, but I try to reply as best as I can. And I know many of my colleagues do the same. So obviously reaching out through email is a very important thing to do. Conferences are great, especially in person. We'll see with Gather Town and so on. I'm a gamer, so I like this gaming aspect of the application, but at the same time, in the conference, I've seen many good connections being made, between people that are less or more senior and so on. So sadly, this year is not going to be like that, but I think going to conferences is a great way to do it. And then maybe depending on where you are in your career, I've attended a few summer schools style, places where people go there to learn. And then usually the speakers are very happy to hang out with the students. So that's also another great opportunity for an in-person interaction, very close interaction actually with some of the leaders in whatever field you're interested in.
Yeah, that's true. I've done that myself too, and I guess we can always reach senior researchers, although we see them as the stars. We just have to try, and yeah, I encourage everyone to do that. In the line of that question, do you think there's although we have now all the connection and remote work that allows us to reach senior researchers, do you think there's a way to attract maybe these senior researchers to work even closely with Latin American countries, or even to like go and teach in one of these universities some semesters?
Yeah, I mean, that's a very good and obviously point. The question is on point given the theme of the workshop. Um, I've seen obviously through the summer schools, like I know, I mean, there's LatinX organizing one. I actually attended Kipu just a year ago, which seems like a long time ago, but I was very happy to go to Uruguay, to Montevideo. So I think these emergence of these summer schools will create these opportunities for at least very kind of short-term interactions, at least with really many researchers that should both themselves see the energy that there is in South America. I really enjoyed Kipu very much, actually, in late 2019. So I think on the one hand, these events hopefully are interrupted by these only momentarily, but will keep happening. And then I know that then there's quite a few people thinking of doing sabbaticals. That happens perhaps more in universities and whatnot. But I know that there are quite a few great opportunities for longer term interaction. And I also know from more having knowledge about industrial academic labs that there are quite a few, that expanding to South America is, or it has happened, or it will happen in the future, because it's obviously a very large population of extremely talented, brilliant people bring a different perspective to many problems. So I think just making sure that we don't stop, or we kind of empower these kind of changes and we accelerate them. There's going to be far more opportunities to have these interactions. But yeah, I mean, otherwise, reaching out internships for you to also travel outside and come back, that also is a very ideal way to kind of cross-pollinate, right, the ways of thinking and styles. Thanking you very much for being in this very special day, an event organized by LatinX in AI. I am here to answer any questions you might have about either of the two parts of the talk, and I really hope you have enjoyed this. Thank you very much.